So how do I get this from?
One mole over 1.
No, it isn't gonna work.
All right. So I have 1 mole for every 126 grams. So if, for my example, if I started with 2 grams, that would mean I'd have how many moles of oxalic acid in the bottom? 0.015 moles of oxalic acid. Okay? Now, if I know, for my example, if I know that this is how many moles of oxalic acid are starting, how many moles?
How did you get 0.015?
She told me. But it's 2 divided by 126. Just hit a button. Okay. All right. So that's how many moles of oxalic acid are down here. So let me ask you this. From our ratio, how many moles of sodium hydroxide do I need to perfectly neutralize it? To use all of it up?
2
2 what?
moles of sodium hydroxide.
No. I have, if I had 1 mole of oxalic acid, I would need 2 moles of sodium hydroxide.
Yeah.
But I don't have 1 mole, right?
0.030.
Right. I have 0.015 moles of oxalic acid, and I know I need twice as many NaOHs to be able to neutralize it, right? Is everybody okay there?
Mm-hmm.
So it was just calculating 0.015 moles of my ox acid. I know I have 2 NaOHs, or I need 2 NaOHs for every 1 oxalic acid. So therefore, I need 0.030 moles of NaOH, right?
Mm-hmm.
Okay. Now, what you did in the lab was to very, very carefully, you have a solution of NaOH in here, right? And you measured the volume that you put in there, right? So I had a starting volume. Here's my meniscus to start. And then you drained it until this turned perfectly pink, which was when we had the exact right amount of sodium hydroxide in there. And so this difference tells you the volume that you added, right? Okay. If you did it perfectly, and this is one of the reasons why you have to keep starting over if you don't get it really well. If you did it perfectly, if you got nice light pink, that means you have added exactly 0.030 moles of sodium hydroxide in. Okay? That moment it turns pink is when you've hit exactly the right amount of NaOH. So in my example, if I'm dropping this down and this turns nice and light pink and I stop, then I'm like, hey, okay, that pink tells me I have hit that 0.03 moles of NaOH. So now what you can do is, let's say in my example, let's say that the milliliters that were added was 52.5 mils. All right? These are just examples. So if I had added 52.5 mils for in my example, then I would know, because of the pink, that in those 52.5 milliliters, I have delivered 0.030 moles of sodium hydroxide. So the question becomes, what's this concentration of my NaOH? And concentration is in units of molar, meaning moles per liter. And have I measured how many moles of NaOH I have to put in? Yes, I have. I have measured that I've put 0.30 moles of NaOH. And have I measured how many liters I have added? Yes. Now I wrote it as milliliters, but what is this in terms of liters? 0.0525 liters. To go from milliliters to liters is 1,000. 3 spots, yes, because there's 1,000 milliliters in a liter. All right. So then we put our volume, 0.0525 liters. Okay. And when I do that math, that's going to give me what my concentration of my NaOH in that that beaker, or sorry, in the burette, not beaker, in the burette is. So what is that concentration? What's 0.3, wait, no, 0.03, I didn't write it right. 0.030 divided by 0.0525, should be about a little less than 6. 0.6, okay. So 0.57 molar NaOH. This is my example calculation. You should get a molarity when you're done close to what, do you think? 1. Should be close to 1. The reason is because what did I give you? I gave you a labeled one that was labeled 1 molar, right? But what the process that you're doing here is standardizing this. It is not just believing the label, because mistakes happen, things get mixed in, diluted, whatnot. Although these should be good because they were still sealed with that tape, right? So you should get something really close to 1 molar.
We got 1.
Oh, see how awesome you are? All right. So when you get that calculation, then that's telling you you are standardized and you are very, very sure of the concentration of NaOH up here. Okay? That's the first half of the lab. The second half of the lab is now that you know, through your calculations, what the exact concentration of NaOH is that you're going to use in the beaker, I'm going to give you a sample of sulfuric acid. All right, so part 2, this is part 1, so part 2, you're going to have the same setup. You know your concentration of NaOH. Remember I said that bracket like that means concentration. You know this. I'm going to give you an unknown concentration of sulfuric acid, H2SO4. So now you're going to put a volume of sulfuric acid in the bottom. So you'll have in your Erlenmeyer. Wow, that's awful. You're going to have your sulfuric acid here. And you'll know the volume exactly that you put in. And then you're going to add and you're going to titrate using the NaOH that you now know exactly what concentration it is. And you're going to calculate what our concentration of H2SO4 is. So your homework tonight is to do 2 things. One is to do these calculations for your data, which if you already have, that's awesome, right? But in addition, it is to write out your procedure that you're going to do to determine the concentration of H2SO4. So basically, you're repeating what you did today. Per part.
But with different numbers?
Well, different numbers and a different acid. But notice this also has 2 hydrogens on here, right? So we standardized with the 2 acidic hydrogens. We're going to titrate with 2 acidic hydrogens. Yes.
Makes you die.
No. Hydrofluoric acid makes you die. This one just can give you a nasty burn if you don't wash it off. Just like the sodium hydroxide that you have in there, if you left that, if you didn't wash it, you wouldn't notice it until like partway through lunch, and then it'd be like a little itchy.
I got one underneath my ring.
Yep.
Like it collected under there.
And you notice it, and then it gets itchy, and then it gets a little bit painful, and it gets stingy, and yep. So just wash your hands. I mean, there's nothing, I will not do anything here that's going to greatly harm you, okay? But you need to write out your procedure. So basically, just think about what you did today and yesterday, and maybe tomorrow if you have to keep redoing it. But which you're not going to, because this one's going to be perfect for that. And write down your procedure, because you can't just copy down what's that step 1, step 2, step 3, because you did things slightly differently, right? You didn't follow that procedure 100%. Kiss me.
So will the sulfuric acid still be a 1 to 2 ratio to the?
Yes. It will still be a 1 to 2 because that's why I did that with a 2. Or otherwise I would have given you a different acid. Okay?